Hello everyone, this is the solution video to homework 1. Now, when the homework was announced, you got actually these three files here. The student.c file, the main.c file, and then you also got the compile.bat file. Now, the compile.bat file is basically indicating you that you have to compile both of them at once, because they will depend on each other when you're testing it. So if you're using an IDE or whatsoever, if you have a project include your files, you should be okay. If you don't, if you're using code editor like VS Code or Notepad++ like I do, and you have this compile.bat file, then you're again good to go. So now there are some indicators here. Submit this file. You should have only submitted this file, student.c file, not the main.c file. And the reason for that is that I'll use a different main.c file when I'm grading your basically homework. So yeah, what do we have here? First of all, we have the same function over here in main.c file and also here on student.c file. Again, since we have two questions, we have also the polynomial, the derivative of the polynomial, and the iterate functions over here. And then we have them also over here. On the right hand side, you can see that we have the implementation may go here indicators here. That means that, and I'm going to show you in a minute, that the implementation should go here, not here. So I'm kind of helping you out throughout the whole thing here. And when you test the functions for question 1, you can just do it here, or for question 2, you could do it here. But the thing that I'm interested in here is basically the implementation of iterate and the implementation of generate, and nothing else. So what was the first question? Well, the first question was the following. We had to write a function void generate that takes an integer. We can do that using scanf, and the scanf code should be here. And it produces this pattern here. We should use printf 3%3d. Hard coding is not allowed. You have to use for loops, etc., etc. It is more about the pattern generating algorithm than itself. The question is pretty straightforward. And you can see here that we have basically the pattern here. So what is going to be the approach that I'm going to take? It may differ for you. You could have thought about something else. But what I'm going to do is the following. First of all, when I have this structure here, I immediately recognize that how many rows or even columns, because it will be a square structure, I need to have is basically quite simple. When we have an integer n, let's say 5, I can see that there will always be 1 in the middle, and it will count through up to the edge, for example to the left or to the right, up to 5. And then I will also have a count from 2 to 5. So basically what I'm trying to tell is the following. I have 5, 4, 3, 2, 1, and then 2, 3, 4, 5. If I separate this like this, I can see that there are 5 of them. So I have basically n digits here. But here I will have basically, if I had 1 here, it would be n plus n, like this. But since we are missing just 1, and the 1 appears on this structure just once, it means that I have basically 1 missing. So n plus n minus 1 or n minus 1 plus n would be the amount of digits that I need here. So let's call this something like int len. This will be the width or height of my whole screen that I'm going to print here. So what then? Well, if I know the len, and I know that I'm going to start with the first row here, what I can do is I can just use a for loop. a for loop int I equals 1 up to length I plus plus. Since I have calculated length, I'm going to printf percentage 3D and then basically n. So let's actually also call this function with 5. So I'm going to go here, do nothing, just add generate and then 5. You could also use scanf here if you want, integer n and then printf and then scanf. This could all happen here, but since I'm trying to explain the whole thing, I'm going to skip on this. If you have any printf, scanf, if you're wondering where I should do this, well, this is the place. Now let's compile this basically. There we go, we've compiled it. Now I have a main function, and there we go. Now, is this correct? Let's see. 5, 4, 3, 2, 1, 2, 3, 4, 5. So this is basically the first row of my output. So my strategy is going to be basically based on this. But I need to somehow come up with this part here, where I start with 5, and then I continue with 4s, and then print a 5, and kind of repeat this up to a certain point. Now, how can I do stuff like that? Well, it is not going to be easy to explain this, because it is kind of a nested for loop kind of stuff, but let's dive into it. Now, what I know is the following. If I have the second row, for example, I know that I'm going to print a 5, and then I'm going to print some 4s, and then I'm again printing some 5s. But it seems to me like that we have actually, if you look somewhere here, we have actually this strange behavior where we have to print, for example, 5, 4, 3, which could be one for loop on its own, and then we have a bunch of 2s, that could be another for loop, and then again we have 3, 4, 5, which is another for loop. So what I'm suggesting is that we have a for loop like this. We'll have another one and another one. Of course, this is happening in just one row. It means that this will be probably in another for loop. So let's think about the first for loop that could be the case. I want to start with I equals n, because it would be 5 in the second row. And then it should decrease. So it should decrease. So let's write this like n, maybe n minus 1, I guess, because n is 5, so n minus 1 would be 4. So it should start with 5, stop at 4 if it's greater than 4. In this case, it will stop directly, and then it should decrease. So we have this 5, 4, 3, 2 kind of thing going on there. What else? Well, if I have this, I'll also have the inverse of this. So int I equals, I guess, n minus I, and then I is greater than or equal to n, and then I plus plus. So why did I write this down? Basically because we have the reverse behavior, 5, 4, 3. I mean 5, 4, 3 here, and then a bunch of 2s, and then we start from the reverse here, so 3, 4, 5. So if I have a certain for loop here, I'll have the same for loop backwards. So this is basically the mentality that I'm trying to, that I have now. And in between these, I'm going to, again, let's have I. Well, I'm going to have bunch of same numbers. So let me just take this here. Let me add it here. So this would be I. We're going to have some increments or decrements here. But in this case, it's going to be a bit complicated because we don't really want to have I here. So it's not going to be I dependent, even though I will have I. And yeah, how many for this example we have just one print here, one print here. I don't know where to start, but I certainly know where to stop because I have len minus basically 2, because I should print 1 here, a 5 here, and another 5 here, so the remaining would be this here. And since I'm at it, I know that n is 5, and n minus 1 would be 4, so this should basically somehow work for, let's have I++. And since I'm counting here, I guess it is going to be starting from 1 up to len minus 2, I++. So yeah, I'm trying to print the second row here, basically. Start with 5, do it just once, so if it's greater than n minus 1, it would be basically greater than 4. That is only satisfied with 5. If it's 4, it should be greater than or equal to. And I is decreasing, because we are decreasing here. And it is the backwards strategy here. We start with n minus 1, go up to n, but this time we increase it. And these are basically counting upwards or downwards. But here, for the second row, we will have just this n minus 1, because we want to print bunch of 4s between the 5s. And the amount of that, because we have a fixed width, and that's len, and we subtract 2 from it, is basically the amount of 4s that we need here. So if I didn't mess up, we should be seeing the second row. Of course, I forgot something. Let's printf a new line. And did we again mess up something? Oh, I guess it should be less than or equal to. There we go. Now you get the idea here, because yeah, this 5 is the first 4 here, the first for loop. These bunch of 4s are here, and the reason why we subtracted 2 from the length is given, and we have 1 5 over here, and it's symmetric, another one over here, so minus 2. This increases, but the printf doesn't depend on I, it's just printing the same number over and over again, whereas the other ones count upwards and downwards. Of course, I can copy and paste it and go on like that, but then I cannot adapt to any n value. Therefore, I already assumed that I will have a for loop here. So let's start another for loop. Let's surround them with for loops. It seems like here we will have another printf new line, because here we are done with a line. Now, it starts from 1, but I'm not quite sure. Let's think about it. Can we... I don't know what the upper limit is going to be for now. But we're going to come up with something. Let's say 3, for some reason. Now, what is the important thing that we should think about? Well, if it's the first row, we have 1, 5. If it's the second row, we can see that the for loop should run twice. So 5, 4, and then it stops. Here again, 4, 5. And in between we will have 3s. So it kind of is determining how many times this for loop should work. So it starts with 1, it works for 1, so it seems like this should be j, because if it becomes 2, I'll get n minus 2 here, and from n to n minus 2 it will print out n and n minus 1, which would be 5 and 4. And here, well, since we have two elements printed out here and two elements printed out here, and this will be again n minus j here, because of the backwards thing here, this is basically becoming 2 times j. And well, because we have 2 here and 2 here, and if j is 2, we subtract 4, and we should subtract 4. Of course, here again, we need to write down something else. For example, if j is equal to 2, n minus 2 would correspond to 3. So you kind of see that just trying to code it for one row and then trying to generalize it is not a bad strategy at all. So, let's try it out first. Now we can see that stuff comes together, 5, 4, 4, 4, 4, 5, and then 5, 4, 3, and a bunch of 3s, and then 4, 5, and then 5, 4, 3, 3, 4, 5, bunch of 2s. So, how long should we go on? That's basically the problem now. And, yeah. I guess when we reach somewhere here, the one in the middle should run 1 time. So I guess since we have n plus n minus 1 here, what do we subtract from it to get 1? So n minus 1 would get rid of that, and minus n minus, so I guess this works here, because minus 2n plus 2 minus 1 gives 1. So the upper limit here should be n minus 1. There we go. Because the for loop in the middle should just run once, because we will print it out once. Now we have completed the task halfway. So what we can do is now, and it seems like that we're just going to do the inverse of the outer for loop here. Instead of now increasing, it should start decreasing and print out everything that it does already. So let's start from n minus 1 up to basically 1 and j minus minus. Will I change anything in here? I think not. Let's try it out. Yeah, it does work, and it also doesn't work. So we can see that there's a duplication here, which is not needed. So you can either change this for loop, the ending point here, or the starting point from here. So if I change it to this, I guess it should be good to go. And of course we're stopping at 544445, which means that this for loop here is still needed. So let's come down to this. And I guess we don't change anything because it's just printing the same number over and over again. So let's compile it. Let's run it. So a box of 5, a box of 4, box of 3, box of 2, there, and then a 1. So this seems to be the code. Let's try it out for different values. Let's have 10. So 10, 9, 8, 7, 6, 5, 4, 3, 2. It seems to be working like expected. Now of course I can also go ahead and do something like this. Open up a command line. Let me first change this. So let's do actually this stuff here for testing. Enter a number. What was the limitation on that? Between 2 and 30. And then scanf %d into n, and then let's call it with n. So this is basically the piece of code that I need to write down here for testing this. Now let's compile it. So I created an external one here because I'm going to say main, and then print in, for example, 10, hopefully, and then we get the structure here. So print main, try 30. Now of course we have this issue, the scaling issue here, but you can see we kind of generate the same. If I zoom in a little bit, we generate this nice structure where we have 30s and then boxes inside and boxes of inside of boxes until we reach the middle here, which we have just where we have just the number 1 here. So this was basically the first part of your homework. So let's get rid of this. Now you can see that this is basically the library that you kind of code and you just implement it, and I'm interested in this file because I'm going to have my own main file that may try different generates and look for the result, for example like 2 and 30, and if they work for them then it's okay, something like that. So therefore I don't really need your main file at all. So once we're done with that, let's go over to our next question here, which was basically a polynomial root solving algorithm. It is called the Newton-Raphson method, the Newton's method actually, and we have an initial point that is going to be 0, and we're going to plug it into our polynomial and the derivative of our polynomial. Yeah, and it should kind of calculate the root as far as correct as possible to a certain limit. So when we use this, let's assume this is the math library. When we use this, then the math library here does not really care what the internals are, but the iterate function here only cares about how to call them or what the protocol is. If I provide a certain double value, I'll get a certain double value back. That's the most important thing for this file here. But here we can implement these functions and call this iterate function and see what the solution is going to be. So that's basically it. Now, therefore, we have this implementation may go here. I'm going to just implement it here. And let's have double x like this. Let's have 3 times x plus 4 times x for some reason. So 3x squared plus 4, or should we complicate it a little bit more? Let's have x cubed plus 2 times x plus 3. So this is going to be our polynomial, and we're going to return that. Let's also implement the derivative. X cubed should be 3 times x squared, and this part should be 2 times x, so 4x. There's not going to be anything else. So we're going to return that, and we take in double x like this. So now here the user provides basically some functions, and down here what we need to do is we need to call this function here. Let's basically have a double x, let's say 1, and all we need to do is iterate x and then printf basically what the solution is. Let's have %lf because it's a double value. Let's add a new line and then x. So this is basically the usage. We are just going to call iterate once, and we will hope that it'll do the job. So we defined a variable, we called our iterate function, we basically implemented our polynomial and derivative of the polynomial, and we printf the result that we have. We are going to give it a 0, but I just randomly put in 1. It's not really that big of a deal. Now, on the implementation of this. So we kind of will use the recursive algorithm. So let's start with that. Well, first of all, we have basically x here. So let me call it x, by the way. So we're provided an x, and the way that we will basically calculate our next value will be polynomial x, because that's the method here, polynomial x, divided by the derivative polynomial x. So I'm basically implementing the same thing here. I'm just writing down n is the time instant, or the guess, the nth guess, and n plus 1 will be the next guess. So I'm basically implementing this thing here, this equation here, or this rule here. And basically what I'm going to do is, because this is going to be plugged in into iterate again, I will call iterate based upon this. So if we would have used a for loop, we would just iterate and have an initial guess and iterate through it, x is 1, and then for certain for loops just do this based on x, so x equals this. This would be basically the for loop approach that we would take. But in this case I'm not going to use it because we are trying to code it recursively. So basically this is xn plus 1, I can just send it to iterate back. So I'm going to do that. So return iterate the new value. Seems simple. But the problem is this. If you're using recursion, you have to have a stopping point or a stopping condition. So we need that in this case. And how can we determine that? Well, we need a certain if statement. If something is happening, then we don't really need to iterate anymore. But if not, then just return that. If we're still quite not there, we need to iterate. But if something happens, then we might stop. So when do we actually stop in this algorithm? That's the critical part here. Well, we know for a fact that since we have a polynomial and it should be equal to 0, we are trying to basically solve x cubed plus 2x squared plus 3 equals 0. So it's important to note that, well, the polynomial satisfies itself. If we reach the root, if we plug it in into pol, it should be close to 0. Ideally it should be 0, but numerically it should be close to 0. So what we can do is we can use something like pol and x at this point and see if this value is basically small enough. It could be positive, negative, so you might want to use something like minus 1e2 or 0.01 and then 0.01. In this interval, I'm okay with it. So this would be a certain error there, but you could be okay with that, or you could even be a bit more precise. Or you can use the absolute value, which is basically the same. So we have f_abs. So if this happens, then we basically have solved it. And therefore, since we have solved it, the solution would be correct. So we could just return that. So I like to use the scientific notation here, 10 to the power of -2. And yeah, this is basically it. If we have this condition satisfied, if it's satisfied, it means that this is approximately 0, and if it's approximately 0, it's the root of that. And other than that, we just need to correct it with this update, which will be the new x value, and then we again return it with iterate, so it does it over and over again. Once it is hitting this condition, we are basically happy with the solution, with the accuracy of the solution. So let's basically compile this now. Let's hit main, and we have a certain value here. So we can change this. And you can see sometimes that if we plug it 0, then we end up in having an error here. And the reason for that is the following. Because we have a dipole x here, if we plug in x equals 0, then basically what happens is that we get a division by 0. So it is quite important to avoid that, since if we start with 0, we divide by 0 and everything crashes. So therefore, if I have this, for example, here, there we go, we have 248. If we want to have 0, what we need to do is we need to pick a close number to it, and it would give us the result. And yeah, we can see that the solution around 0 or around 1 is basically 2.485592. So we can go ahead and check if it's correct, but the only thing that at this point is important is that we have implemented this here. even though I've given this initial guess to be equal to 0, what we can do, which I didn't touch base on, is that we might want to check if the pole is 0. If it's the case, update x with a certain different number, a random number maybe, or a higher value than 0 for x. We can include that check in here, but I didn't want to bother you with that if statement because it's straightforward anyway. So yeah, this is basically the solution. And if you look close to it, let me get rid of this terminal here. We have basically the solution to homework 1. You see the whole generate function here. We have a iterate function here, and all that you have to do is submit this file and you're good to go. This basically depends on the tests that you want to run, but other than that, this is the solution of homework 1. So, see you in the next homeworks, next videos.